Over the last year or so, we've seen the strongest LLMs and AI agents pretty much saturate all the benchmarks, especially if you compare relative to human performance, whether it's reading comprehension, language understanding, image recognition, and so on. Even all the math benchmarks like grade school math and so on. And now we've been constructing more and more challenging benchmarks. There's ARC2, there's the International Math Olympiad benchmark, but these represent the very, very tippy top of human cognition and problem solving. So the question is, what should we be measuring next? And Meta, which is an AI model evaluation lab, came up with this really interesting metric, which is to measure AI agents' ability to complete long tasks as measured by how long it would take a human to do it. And what they found was a really consistent Moore's law kind of exponential, which is really fascinating. As they say over here, consistently exponentially increasing over the past 6 years with a doubling time of around 7 months, which is astounding because with Moore's law, the doubling time was around 18 months to 2 years. This is the headline graph. What they have on the x-axis is time with some of the latest models available at the time. And on the y-axis, they have tasks along with how long a human typically would take to complete that task. And note that the y-axis is logarithmic. So the straight line that you're seeing here is actually an exponential. Another way of expressing the same statistic is what is the probability that an AI agent can complete a task that takes a human some given length of time. And currently, what they're finding is that models have a nearly 100% success rate on tasks taking humans less than 4 minutes, but less than 10% success rate when you increase the task time, the human task time, up to 4 hours. And here you can see that same expression in a graph where on the x-axis you have the time it would take a human to complete it, and on the y-axis you have the model success rate. And you see how as the task length goes beyond a few tens of minutes, the success rate sharply drops. But as that headline graph at the beginning was showing, the latest models are able to push that boundary out further and further. So they're succeeding at increasingly longer tasks. As I say over here, the latest model, Claude 3.7, which is this dark green area over here, has a time horizon of about 1 hour. And this really is the goal of everyone constructing AI agents. They want these agents to sustain intent for longer and longer periods of time. And that also corresponds, in some sense, to the complexity of the task, because that's what humans are doing. Humans aren't just accomplishing one simple task that takes a few minutes or a few hours. They're holding intent over very many tasks over a very long period of time. If you look at what, say, a manager or a product manager is doing at a large company, they're holding a goal over quarters or years while still accomplishing more granular tasks in the meanwhile. So let me wrap up with their prediction. They say if the measured trend over the past 6 years that they saw continues for another 2 to 4 years, agents will be capable of performing a wide range of week-long tasks. And that is a really interesting threshold because, especially in software engineering teams, people plan their tasks over 2 week sprints or month-long sprints. So as you start approaching this time threshold of what would have taken a human a week or 2 weeks, you can really start offloading more complex, more higher level tasks to AI agents. So there's the data. The curves are curving, the exponentials are proceeding along a very nicely fitted line, and the next few years are going to be very, very interesting. All right, thanks.